Okay, here's the next video. It's a short one. It should take less than about 10 minutes for us to blitz through the rest of chapter 8. When can you use this method? You gotta have a fair sample, simple random sample of pairs. There are methods that we could use to deal with stratified samples of pairs and other methods of sampling, cluster sampling, etc. But in our class, basically think simple random sample is the method that we work with. And these other sampling methods that we have identified, they will be appropriate as long as there's randomness. And instead of a sample of pairs, perhaps somehow pairs could be naturally created. And then we treat the pairs differently. For example, if I wanted to make sure that a writing program was effective in a particular class, one of those GWR replacement classes, instead of taking the graduate writing examination, um, you could take a class. And the classes in theory should teach you how well you could write. So maybe what we could do is have, based on the students' first essay scores, have the top two students paired together, and the second two students paired together, and the third pair of students paired together. That's through the top 6 students overall, and then all the way down to the worst scores on the first essay. People who have real grammar problems and spelling problems and the whole like. If that were the case, then presumably, if by flip of a coin among the first pair, the two highest scores, one of them is assigned into section A, where they're treated one way, and one of them is assigned to section B, where they're treated differently. And then in the second two pairs, we could assign at random one to be in the treatment and one to be in the control group. And if randomness is used, but the pairing is based on the initial score, we could make sure that we've got a fair set of pairs across the whole of our experimental group. So either large sample sizes or the distribution of the differences must be normal. And we can use chapter 4, section 4, a normal probability plot or a normal quantile plot to check that, or maybe a histogram, if you will. Does the pairing help? Well, the pairing is going to help us in the situation where if I were to see a scatter plot of the two scores, I see a positive relationship. So let me see if I could pull out that not the schizophrenia, but the sunscreen data set, because that's sort of a fun one. I want to know how effective sunscreen is, and so the way I'm going to do that is, where's my data set on sunscreen? Okay, here we got the data on the sunscreen. A group of individuals volunteered to be part of a sunscreen experiment to see if they, by using sunscreen, could increase the length of time they could be in the sun before they turn crispy. The control group is actually not a control group, it's a control arm. On the control arm, they applied regular lotion that is not sunscreen lotion. It had the scent of a sunscreen, just like the sunscreen arm had the scent of a sunscreen, but the control lotion had nothing that prevents sun damage. And so they have the people lay in a tanning bed, and then every initially 5 minutes they check them and they see if there's any noticeable signs of sun damage with the control arm, okay, and then with the sunscreen arm. And then they just cover up that arm when there is noticeable damage, and they mark the time at which they first see it. They start out every 5 minutes, then they eventually move to every 10 minutes, then every 15 minutes, then even longer than that. I think eventually they get to every 20 minutes or so. Okay, so let's look at these data in the context of a scatter plot. I sort of want to know if there's a positive relationship between the amount of time a person could be in the sun with sunscreen versus if they have no sunscreen on, if they're in the control group. Do you all see a positive trend? I see a positive trend. In a positive trend like this, there is definitely a benefit of the pairing. Let's rephrase that. The margin of error using the paired method will be narrower than if I use the independent samples method, which is wrong anyway. If I do a hypothesis test, the p-value will be lower than if I use the incorrect independent samples hypothesis test. So the pairing will definitely help. Usually what it boils down to is you go for paired data if on average you can. If on average you can find natural pairs, it's a good idea. Okay, so I might want to know if among married husband-wife couples, the male is older on average than the female in the couple. I mean, sometimes yes, sometimes no. We can all name celebrities where that's not the case, where they married people of very unusual age pairs. But I'm thinking if in general, the older the husband, the older the wife, we're going to tend to see with more precision in the paired analysis, we're going to tend to see the increase in the age of the husband relative to the wife more easily. To illustrate how silly this is, if we did it incorrectly, suppose I want to go down to farmer's market Thursday in San Luis, and suppose we're even having one. I could walk up to a person and say, hey, are you married? And if they say yes, I could say, how old are you? And they tell me their age, and then I just wander away. And then I could find someone else and say, are you married? And they'd say yes, and I'd say, how old are you? And I'd mark down their sex and then their age and wander away. Now, if you see two people that are clearly paired up and you ask them, are you married to each other? And they say yes. And then you say, how old are you and how old are you? That's more natural rather than getting the information from just one of the two individuals. That natural pairing, if you find it easily available, work with it. It will save you. Okay. Last thing about chapter 8. Just because mu sub d may be 0 or not doesn't mean that everyone experiences that same benefit. Just because on average in a before and after study, a blood pressure may drop on average doesn't mean everyone will benefit from a drop in blood pressure if they were to take that medication. Not all individuals will have the exact same trend. That should be no surprise. Lastly, I want to point towards the end of chapter 8, which again, virus, we're not going to be covering. But I'm going to say that like in chapter 7, the end parts that we ignored, in chapter 8, the end parts that we're ignoring in our book basically say if we have a small sample size and we're not willing to assume normality in the differences, there is a collection of other methods we could use to tackle the problem. However, you're not responsible to know those things. So with that in mind, we're going to be done for the day today. Enjoy the rest of your day. Goodbye.